What's up, AP Stats? Mr. Mudo here, lesson 1.10. The learning objective for today is to compare box plots of distributions. So for this lesson, I have one box plot here, and we're just going to describe the situation and describe the distributions between these two different box plots, I should say. The first box plot, letter A, the top one over here, is speaking of female actors, and we're looking at the ages of these female Oscar award-winning actresses for letter A, from 1975 to 2004. So like this minimum value here denotes that there was a female around the age of maybe 21, 22. She won an Oscar at some point between 1975 and 2004. And maybe this point way out here, we have like an 80-year-old who won an Oscar at some point. And those were both females because they're in the first box plot. And then the second box plot B here, this is referencing the male actors. And we can see that the distribution looks a little different. So we want to compare these two distributions. In comparing these two distributions, we want to talk about the shapes, the center, spreads, and then any unusual features. And then like very quickly, we'll go through each of these. So the shapes, with box plots, you can't talk about the number of modes. You can't talk about the number of peaks because you can't see that in a box plot. What you can see in a box plot is the symmetry. Are they symmetrical? Are they skewed? And once again, let's just look at box plot A. So this is female actresses. If you just look at the box plot, it looks pretty symmetrical, but we need to recognize that we do have high outliers. And if we were to actually connect these high outliers to our box plot, it would make a box plot that's heavily skewed right. So for box plot A, I would say this is skewed right. Box plot B is pretty similar, maybe not as skewed, but there definitely is a high outlier. So that one's also skewed right. Now the center. For measures of center that we can speak towards the mean or the median. Now, in certain situations, it's going to be very beneficial to you to pick one of those. Now, given that we have the box plots, we don't actually have every data piece. Like right now, we don't know how many female actresses this box plot represents. We don't know if we're talking about 40 actresses or 10 actresses or whatever. So we can't actually calculate the average because they didn't give it to us. We can't calculate the mean. What we do have is the median, and the median is given to us right in the box plot. So for the females, it's like right about 35. For the male, it's about 43. So maybe I'll say I'll go 42. And this is, of course, the median. The median age. All right, spread. For spread, you can speak, since we talked about the median, you can speak towards the range or the interquartile range. And either of those would be very appropriate. I've been mostly talking about range with our examples, so I'm just going to do the IQR for this example. And remember, for the IQR, you have to look at how big is your box. How wide is your box? Remember, this is Q3, and this is Q1. This is Q3. This is Q1. And what this box is made of is the middle 50% of your data. Remember that each of these pieces is 25%. So the middle 50% of your data lives inside of your interquartile range. So we want to see how spread out is that middle 50%. Well, to figure out the IQR, let's do for the females first. It looks like Q3 is at about 41, and Q1 is at about 31. So 41 minus 31, that gives us a spread of 10 for the interquartile range. And for the males, looks like it's 51 for Q3 and about 37. So it looks like the males have a larger spread when it comes to the interquartile range. And any unusual features. Now remember, with this, we can speak about gaps or outliers. You can't see any gaps in box plots. Those are usually for histograms. But we do see that there are outliers, right? So for the females, we have 3 high outliers. That's these 3 up here. Where the males have just 1 high outlier. All right, and that's comparing their distributions. Now, when it comes to the AP test, this answer that I just gave is definitely not enough to earn yourself a passing score. When it comes to the AP test, you're actually going to have to write this out in sentences, and you're going to have to use comparative language. So I'll actually go ahead and do that right now. But I first want to write this down first, and then use this information to make our sentences. So here's what I can say. The distributions for the male and female ages of Oscar winning actors are both skewed right. I'm going to have to move this guy down. So these are both skewed right. So that covers our shape. The center. So I recognize that my center for the females is lower than the center for the males. It is not okay to just say the center for the females is 35. The center for the males is 42. That is not comparing. In order to actually compare these, you need to mention words like higher than, lower than, or equal to. So for this one, I can say something like the median age for female is lower than for males since 35 is lower than 42. Okay, that's just how I worded it. You could have worded it a little differently there, as long as you have comparative language. And in this case, it'd be lower than. And then the spread, the interquartile range. So again, the range was found higher for that of the males. So I can say the IQR for males was 14, which is higher than for females at 10. Last thing would be to mention the unusual features. So we know that they both have high outliers. So we can say both distributions have high outliers. The females have 3. The males have 1. Alright, so again, when describing these distributions, shape, center, spread, unusual features. For the AP test, you're actually going to have to write a paragraph where you speak of these 4 things, I should say. Shape, center, spread, unusual features. And we will get more practice with this, definitely as the year goes on. Now, what I want you guys to do is a little check for your understanding. Let's see if we can zoom into this. All right, so here we have a distribution, 2 different distributions. We have the average high temperature in San Francisco versus the average high temperature in Pittsburgh. And we can see that these 2 box plots, these are actually vertical box plots. It's the same thing though. And they look very different. So let's answer a few questions about these. Let's compare the shapes. Let's compare the centers. Let's compare the spread. And let's compare any unusual features.